If you watched football on the television recently, you must have seen this. A graph called match momentum. It rises, it falls, sometimes it spends like 10 minutes in one team's favor. But what is it really measuring? And can one graph tell you the story about the whole football match? Football has always had statistics. Possession, number of shots, shots on target, corner kicks, and so on. But here is the problem. Imagine Team A has 70% of ball possession, but they only exchange passes between the defenders. In the same time, Team B has only 30% of ball possession, but each time they get the ball, they make a quick counter-attack and create very dangerous chances to score the goal. So who looks more dangerous? Who is more likely to win the game? Well, it depends if you look at the statistics or ask any football fan. Clearly, the traditional statistics don't tell you the whole story. So here comes this idea of a match momentum. A momentum graph isn't trying to predict the future. It isn't saying this team is likely to score, this team is likely to score. Instead, it tries to capture something else, something that you intuitively recognize but struggle to measure, and that is which team is currently trying the most, which team is making the other team defend, or put simply, who is knocking on the door. And momentum is a numerical attempt to quantify this. Let's watch this attack. The goalkeeper starts the move, a short pass, nothing's really going on. Another pass to the midfield, still fairly harmless. But now watch what happens. A line-breaking pass, the ball reaches the penalty box, then a cross, cleared, but only as far as to another attacker. Ball is recovered immediately, there's another cross, blocked shot, corner, header, saved, still no goal. But look at the momentum gauge. Notice how it keeps climbing. It's not because of a single action, but because the attacks keep coming. One team is forcing the other deeper and deeper into the defense. They are knocking on the door. So how does the computer recognize this? Modern systems, they learn from millions of football actions. They learn to recognize patterns, and they are able to understand that not every action has the same importance. A sideways pass or a backward pass to the goalkeeper? Hardly any importance, really. But a pass that breaks through the defensive lines? Oh, that's a different story. Recovering the ball immediately after clearance? That's again important. A dangerous cross, a shot, a corner, all of those are very important events. And each such event nudges the score a little. And when we combine all of those events, we get a single number, usually between -1 and +1. When we calculate this for every minute of the match, we get a plot like the one that you see, the momentum plot. If you are into machine learning and data science, you can think of momentum as a latent variable. We cannot see it directly, but we can infer it, estimate it, from the observed events. Crosses, passes, corner kicks, shots on goal, and so on. Now let's look at another interesting example. Watch the ball. One team keeps possession of the ball almost half a minute. Pass, pass, backwards, sideways, back again. If all you are looking at is the possession, you would think they are dominating. But look at the momentum. Barely moves. Because possession itself does not matter. It's what you do with the possession. Now let's look at the case where a simple momentum model would get confused. For most of this sequence, Team B has the ball high up the pitch. Then interception. Long pass. Suddenly it's one-on-one. Goal! This is one reason momentum models don't just track where the ball is. They also pay attention how the attack is developed. Breaking defensive lines, fast transitions. All of these are very important, not just the territory. But here's my favorite example. Cross. Cleared. Recovered, cross, blocked, corner, header, saved, recovered again, no goal. Yet look at the momentum. It is almost completely one-sided. And that's exactly what every football fan watching this game would say. They would say, it feels like the goal is coming. But notice that's different from saying that the goal will come. Brilliant goalkeeper like Gianluca Buffon might still save everything. Or an incredible defense might hold on. Momentum isn't predicting the result. It's describing what's happening right now. One last detail. Have you noticed that the graph doesn't just jump after every pass? That's because it has memory. Recent attacks matter the most, but events from a couple of minutes ago gradually fade away. Their importance is reduced. It's just like our own perception of the game. The result of this is the smooth picture of how pressure builds up. So hopefully, having watched this video, the next time you are watching football game, you will know and understand what momentum graph really means. And don't think of it as a prediction. Think of it as a summary. Imagine someone asks you, tell me the story of this match. But you can only draw one picture. The momentum graph is one possible answer. One attempt at trying to summarize the whole football match in one picture. Every dangerous attack, every recovery, every spell of pressure, every moment when one team forced the other to defend. The scoreline tells you what happened, and the momentum graph tells you how we got there. And once you know how to read it, you will never look at it the same way again. So back to this plot. Now you can probably tell what happened. A quiet opening, then one team was dominating pretty much the whole game, and then the other one fought back. Very late surge, and finally the whistle. That's the remarkable thing about this graph. It doesn't just show you the numbers, it tells you the story.